got mad because that was a 4 out of 5 stars, and they changed it to 1. Some other kid, not the kid who wrote the review. Yeah, there's a funny story about Florida on the radio this morning. A Florida woman. I just have to tell that, and everyone's like, oh. See, what Donald Trump, the wall Donald Trump really should be building is the one that keeps everybody from Florida in Florida, because we don't want them outside of Florida. This woman was in Louisiana at a roadside petting zoo, which is apparently something that exists in America. You just drive along the highway and there's a zoo. What? What are you talking about? There's all these little gnomes and things by the windmills. No, that's the mini golf course. I'm just, whatever. Okay. I personally do not hold very much with this, but whatever. So she's at the roadside petting zoo in Louisiana. The roadside petting zoo in Louisiana is a very good representation of the Arabian desert, which it isn't. So, of course, they have camels. Many of you are aware of what camels do when they are unhappy with you. They spit. They do. This woman got spit on by the camel. Now, you and me are intelligent people. A camel spits on us. We go, gross, go to the bathroom, and wash ourselves off. Maybe we might consider spitting on said camel. But of course, that would also be stupid. This woman climbed the fence, entered the camel's enclosure, and bit the camel. Would anyone like to guess on what part of the male camel's body she decided to sink her teeth?
His neck.
Wrong.
His other neck.
Wrong. Braden?
The male camel genitalia.
A particular part, she grabbed a big old mouthful of camel testicle. And it doesn't matter. It's a real thing. Apparently, she felt that that was appropriate. Now, of course, some of you should be aware that a bull's testicles are quite regularly eaten by people. They are called... No. Does anyone know? It is a prairie oyster. Because on the prairies there is no ocean, so therefore there is no oysters. So they eat bull testicles, and they are called prairie oysters. This woman, of course, a camel testicle must obviously be a desert oyster. No. See, Emma, you're missing the point of the story. The point of the story is how stupid this woman was. It doesn't matter what happened to her. I have no idea, because the people telling the story on the radio also did not care about the aftermath. The funny part of the story is this trash heap climbing into the camel enclosure to bite the camel on his testicle. That is the problem. There you go. And when it's on the internet, it must be true. Now, for those of you that think like I do, that Florida must be just a hotbed of absolute insanity, what actually happens is Florida has different laws about what you're allowed to print in the newspaper. So everybody in the world does stupid stuff, but a lot of the people in the world have protection from their own stupidity because of the laws of what is allowed to be published. Florida has no such laws. So when Floridians do stupid things, you can write about it. And those of us that aren't Floridian can laugh. She a good-looking lady there? I can't see her. I don't care. It's an old lady. Well, anyways, let's do math, shall we? I don't even know how we got to Florida. I took a plane. Oh, yeah. You guys want to know that? Yeah, okay. All right. If we are going to graph a linear function, you have been given 3 methods to do so. The first method you got when you were in the 6th or 7th grade. And that first method was to take a table of values. Now you have maybe have had a teacher or two that call it a T-chart. I don't like that nomenclature, but if that's what you know, that's what you know. On a T-chart, you choose X's and Y's, but it doesn't have to be X's and Y's. It is more aptly labeled deep, independent variable, and dependent variable, and you sub them in. Now, I know I've done for you guys that joke where the kid's like, how did you know it was going to be 2, 3, and 4 for X? Because I chose 2, 3, and 4 for X, right? Oh, I didn't. Whenever I show these, for example, X plus 2 equals Y, I say fill in the table of values, and I say let's use 2, 3, and 4. And the kids say, how did you know to use 2, 3, and 4? Word. Well, how did you know? I choose it. And I put 2 for 2, and then I get a result of what? 4. And when I choose 3, I get a result of? 5. And when I choose 4, I get a result of? 6. And when I choose 71, I get a result of? 73. And my students who don't pay attention say, how did you know to use 2, 3, and 4? Exactly. They ask that question. They think I'm some sort of math magician as opposed to a mathematician. And of course, that gives you X's and Y's that you then put on the graph. 2, 4, 3, 5, and so on, right? You all knew that from back in the day. Like when you were 11, you were taught that. Easy peasy lemon squeezy. Then along came Mr. Myers and he said, aha, but kid, could you not choose the x-intercept and the y-intercept? And then, because you know it's going to make a straight line, because there's no exponents, just connect the dots. Right? That's the first thing we did in grade 10. And then we took this bit of information and we recognized that, hey, wait a minute, if I write slope-intercept form, y equals mx plus b, all I need to do is put b on the graph and then count my rise and run. And that's where we are right now, yes?
Yes.
We can do all 3 of those things.
Yes.
Well, the more astute members of the class will notice slope-intercept form. The title of today's lesson is point-slope form. It's another kind of way to graph just by looking. Without doing any tables of values, without doing any math, you can just do it by looking. And being the intelligent young people that you are, slope-intercept form gave us a slope and a y-intercept, correct? I should not have colored those yellow because I've entitled point-slope form yellow. A slope and an intercept, yes? What do you think point-slope form gives us? A point anywhere on the graph and a slope. Point-slope form looks like this. Y minus y. Some people like to write y2 and y1. Some people only like to write a y1. I don't really care how you write it. Equals m x2 minus x1. Now, you should look at that and you should be aware that every single thing in point-slope form is something you already know how to work with, yes?
Yeah.
right? We already know what m is. It's rise over run. We already know that x and the y's just come off the graph, yes? Now, when we write it in this form, x1 and y1 are the known points, which means they are the ones, or that this, I'm going to write this better, x1, y1 is the point we start with. But there's something weird that happens here. Okay? And we're going to show you that before we do too much more. So I'm going to write out a point slope form. Y minus 3 equals 2 over 3 x minus 5. Okay? Now, I haven't told you how to work with this yet, but we're just going to build up to it. Everybody cool?
Yes.
Now, you can see, you tell me what are the points that are at x1 and y1 right now. In this one that I have written out right here. What do you think the starting points are? And if you already know how this one works, do me a favor and keep quiet. What do you think it is, Braden? -5 and -3. Agreed? Everybody cool with that? So if we were going to draw our graph, we would go to -5, -3, which would be down there, correct? And we would have a slope of what? 2 over 3. So let's go up 1, 2, and over 1, 2, 3, which would put me at, I went up 2, I was at -3, so now I'm at -1, right? And I was at -5, and I moved 3 to the right, so I would be at -2. Does everybody agree?
Yes.
Yes, Jacqueline?
In the equation, it says to subtract the second point. So wouldn't it just be positive 5 and positive 3?
You're giving me away. Does everybody agree that this is a point here that should be on the line, but now that Jacqueline's asked, we know it's going to be wrong, right?
Yes.
Is that an x? Is that a y? In this equation, do I have x and y? So what would I put right there? -2. And what would I put right there? No, why? -1. What is -1 minus 3? -4. What is -2 minus 5? -7 times 2/3 is -14 over 3, correct? Does 4 equal 14 over 3? No. So this is wrong, isn't it? Now, what we just said there, or what Jacqueline just asked, is why this is wrong. These are indeed the points you know, right? But this says we have to subtract the point we know. Correct? Right? So it's saying the opposite of the point I know. So therefore, what point should I use? 5 and 3. And now let's check if that works. What's 5 minus 5? 0. And what's 3 minus 3? Does 0 equal 0?
Yes.
You sticking with that answer?
I might change it later.
You're going to change from 0 equals 0?
I was making.
I know. Everybody cool? So yes, it is the point we start with, but because it's minus, we have to remember its opposite. Now, I like to, of course, always show you that it works. So if I go to 5, 3, here I am at 5, 3, agreed?
Yeah.
My slope is 2/3, yes? So if I drop down 2 and go this way, I'm at 2, 1, agreed?
Yes.
Everyone agree? Okay. So x is 2. What's 2 minus 5? Negative 3. What's negative 3 times 2/3? Negative 2. Yeah? And what is, y is 1. What's 1 minus 3? Does negative 2 equal negative 2? Braden. Okay. So does everybody see how it works? The negative sign means we are seeking the opposite, because that's what negative means. It doesn't actually mean subtract. Okay? We remember that 7 minus 5 is actually 7 plus negative 5. So because this is a negative, we seek the opposite. Everybody good? Excuse me. All right, let's see if you're really good. What is my starting point on this line? Other way around, x's go first. What is it? 1, negative 2. And then how would I draw the line? That gets me my first dot. I need at least 2 dots, right?
With the slope of
So where would I go?
to the left 2 and down 3.
Not quite. It's rise over run.
And to the left.
Okay. I could go down 2 and
Left.
right 3 because it's negative. Or what could I do? Down 2 and right 3. Or up 2 and left 3. Does everybody understand? Okay, what's 2? What's my starting point? I seek the opposite. Negative 3 and positive 4. Because I need 0 to equal 0, right? And then what are my options? How do I finish drawing that line? Down 1 and right 4, or up 1 and left 4. Everybody cool? Yeah? Okay. What's weird in 3? There's no apparent slope, is there? Right? Okay, so what do you think our starting point is? Negative 2, negative 1, excellent. And what is this number here doing at that bracket? Mathematically, not graphically. What does that fraction in front of that bracket do math right there? Multiplies, right? Well, I have nothing multiplying there, correct? What is the number that multiplies?
1.
Right. So what's our slope here? 1. Not 1 over 0. That's straight up and down.
0 over 1.
Not 0 over 1. That's flat. 1 over 1. So I could go where?
Up 1 to the
I could go up 1 and left 1? Right 1. It's positive, right? 1 and 1. Or
down 1 and left 1.
down 1 and left 1. Everybody cool?
As the ocean.
Okay. What's 4? What's our starting point? Negative 4 and? No. 0. Because y minus 0 is what?
0.
It's y.
Oh.
Y minus 0.
Oh.
And then what's my slope? What's my slope? So I could go from negative 4, 0, where do I go?
Up 1.
Up 1 and
To the right 1.
1?
2.
2.
I'm tired.
And, or,
Down
and
to the left 2.
left 2. Whew. Okay. What about number 5? What's my starting point? Yeah, you do.
Negative 5, negative 3.
Negative 5, negative 3. And what's my slope? No. -1. So I would go down 1 and
To the right one.
right 1, or
Up one.
up 1 and left 1. Excellent. And lastly, number 6, back to a nice easy one. That's perfectly normal. What's my starting point? 110. And where do I go? Up 4 and right 5, or all right. Now, of those 6, I want you to choose any 3 of them and tell me one other point on the line. You choose the 3. You can talk to your neighbor if you need to. Go.
Hello.
Hi. How are you?
Pretty bad. What does it mean? Hey, come. You got any grapes? The man said no, we only sell lemonade.
Yes, go.
The dog said, go die. Now you all away. You can all away. Whoa. Till the very next day. Bum. Hey, that's pretty good. Hey, Michael, Esau's here. Why are you breathing?
You had to pick 3. I, of course, have done all 6, both going in both directions. Obviously, the black ones are following the black path, and the red ones are following the red path.
I got that one wrong. And I did get that one wrong. What?
Oh, wait. I screwed up the very first one. Sorry. -4 and 2 -4, and the red one was 0 -2. The red one was correct. Oh, now I got to check them all. 3, 1, 3, and I did them backwards in color. Damn it. 5, -7, 5. Then I think I'm right. Sorry, everyone. Up 1. Yeah, I did them backwards. What an idiot. 0. -1, 0, and 3 is -2, -3 is, the red one's right, and then I think I'm right. What an idiot. Up one, that one's right. Yeah, the rest are right. Okay. Sorry about that, everyone. Doughhead in charge today. It's the end of the day. I don't feel too bad.
20 minutes ago, half an hour.
Slightly longer. All right. Now, all we're going to do is practice graphing these 3 times. All we got to, no, 3 questions. So, what do I have here? Do I have a starting point?
Yes.
What is it?
-1, 2, +2.
-1, 2. Where is -1, 2?
Right there.
Where do I go?
You go
Down 1 to the
No.
right 2.
Nope, you go left one.
Oh.
Up.
Left 1, up 2. And then what do I do to count it?
You go up 2, right 3.
Up 2, right 3. I'm going to zoom in on this because these are tough for you guys to see. Where do I go? Up 2, 1, 2, 2, and right 1, 2, 3. And what's the other way I could go? Down 2 and left 1, 2, 3. And then what do I do?
Draw a line.
I draw the line because it's continuous data, yes?
Yes.
Do I need to cover my whole graph or is that good enough?
That's good.
That is more than sufficient. So, 1, 2, and then I could go either up 2, right 3, or down 2, left 3. Yeah?
Yeah.
Okay, let's do the next one. What do we know? What's our starting point?
-5 and
-5, -1, and then I would go either,
-1. Left 5, down 1.
no,
Down 2.
down 2 and
Right 1.
right 1, or
Up 2.
up 2 and left 1. So let's go over and do that. Where's -5, -1?
5 to left 1.
And down 1. And then I would go where?
Up 2 and to 1 to the left.
Up 2, 1 left, or
Down 2. 1.
down 2, 1 right. And then what? Connect the dots. Yeah?
Yeah.
All right. Sir. Ooh, barfy. Let's put together everything we have done so far this year. Read that question. What are some key words that are in there? Perpendicular. Excellent. What else? They're going to cross at the y-axis. What else? We know one of the lines, right? Okay, so I have line 1 and I have line 2. Agreed? What must they share? Their slopes must be opposite reciprocals. What else must they share? Addison? Well, that's what the opposite reciprocal slopes will do. They will give us a 90 degree. They got to cross over. Yeah, one's got to have a positive slope, one's got to have a negative slope, so they can cross over, yeah. What else do they share? Where do they cross? All right, so if one line goes through there, where must the other line go through? Same spot, right? Because they cross at the y-axis. So we got to decide. This is one of the lines right here. So let's make him line 1. 2x minus y plus 8 equals 0. I want the equation of the other line. Well, let's do that. Can I graph that guy?
No.
Not like he is, not unless we use a table of values, right? We don't like tables of values. We're not little kids. We put on our big boy pants, right?
Yeah.
And our big girl pants.
Yeah.
And our big people pants.
Yeah.
And maybe it's our big boy skirt because we're Scottish. And maybe it's our big girl trousers. Huh?
Did you look at animal?
No.
I thought you looked at animal.
No. because maybe we're Scottish. And Scottish dudes sometimes wear kilts. All right. So, what should we do with that if we wanted to graph it like big kids? No.
Algebra.
What? Okay, what would we do algebraically to that to make it so we could graph it in 1 second? Addison.
You isolate the x and the y. Y.
Just the y.
Oh, yeah.
If I move y over here, what do I get? I get 2x plus 8 equals y. Is y by itself? Okay. So what do I now know?
You know the slope and the y-intercept.
And what is the y-intercept? So I put a dot at 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah?
Yeah.
And what's the slope?
Positive 2.
Positive 2. So can I go up 2 and right 1? No, because I'll be off the graph, right? So I better go where? Down 2 and left 1. Down 2, left 1. Everyone agree?
Correct.
Okay. Now I got to deal with line 2. What do I know about line 2?
It's perpendicular.
So what do I know about line 2's slope?
It crosses the y-axis.
No.
It's going to be the opposite.
Opposite and reciprocal. So line 1's slope is what? 2 over 1. So what's line 2's slope? Negative 1 over 2. Right? Right?
Yes.
And what's line 2's, what's the B of line 2? What is line 2's y-intercept? Read the question.
8.
The lines cross at the y-axis. So what is the B of line 2? So what is the equation of the second line? Y equals what? Negative 1 half x plus 8. Easy peasy. Now let's check. Go down 1 over 2. Down 1 over 2. That looks 90 degrees to me. And their slopes are opposite reciprocals. So if I dropped a protractor on that boy, that bad boy, what would I find right there? That it was 90 degrees. Yeah, yeah? Yeah, yeah, yeah. Every dot on this construction is what? Every dot is what? What is every dot on here? Forget the lines we graphed. Just answer my question. What is every single dot on here? One single number? 2 numbers, an X and a Y. Every question that you do deals with an X and a Y. This told me that I had that X and Y and then all of these X and Ys, right? This one told me I had that X and Y and then all of these X and Ys. That's all you're doing this whole unit. If you can wrap your mind around X comma Y can go into these equations, then you can do the rest of math all the way to grade 11. End of grade 11. Okay? Okay. Do work. You've got 23 minutes. Page 142. It looks like a lot. Remember, the further you get to number 22 with the right answers, the higher your marks are going to be on the tests. It's that simple. The more practice you do, the better you'll be.